Welcome to our webinar for today, looking at k0s and Cosmotron at the edge and the various use cases. Now, so today's webinar, we'll talk about various topics such as edge computing scenarios, benefits of running Kubernetes on the edge, and perhaps some of the challenges of running Kubernetes on the edge as well. And then we'll also look at how k0s, an open source Mirantis product, can address these challenges, and also look at how you can deploy your clusters and manage them at scale and with ease.
Need to learn Kubernetes quickly? Check out our free ebook with hands-on exercises you can complete on your laptop over a short break or lunch. Visit mirantis.com/learn k0s to download now.
To start off, my name is Kevin Ng. I will be your host and your presenter for today. I'm a senior solutions architect at Mirantis here, really helping customers, working with them and finding how to path their current state to their desired end goal and providing the right solutions along the way. Before we actually talk about edge use cases and Kubernetes and things like that, let's talk really quickly about what we mean by the edge. I'll know that the term edge or the concept of edge kind of began in the 90s where we had the first content delivery network, so a kami, and putting content closer to the customers, right, the consumers. So these are things, such as video and streaming and data and so on and so forth. But now the edge is a bit more blurry now in 2024. I almost said 23 here. Because if you think about it, the iPhone that I have in my pocket is probably more powerful than the high-end gaming laptop and computer that I built in the 90s, right? And we have all kind of done that. So right now the edge is actually more powerful than before, but let's still put some definitions onto the edge so we know roughly what we're talking about when we talk about the different layers, right? So if we think about this, there are a couple of different, I'll use the word layers to the edge, starting off for our core data centers, right? This is generally your most powerful compute. There's going to be fewer locations, each of them with several nodes and workloads. And this is really the primary host is to host your large scale applications that could process things, serving users worldwide, and things such as data processing, backup, disaster recovery, so on and so forth. These core data centers then will feed into your regional data centers. They'll spread a bit more, and depending on the direction of traffic, will also feed back into the core data centers. Right, so they're going to be more widely distributed than your core data center, probably designed to serve multiple geographic areas and have a number of smaller compute, but still pretty significant in terms of work and workloads as well, right? So you kind of use them for more your localized content delivery and perhaps compliance and data sovereignty, where your servers need to live within a certain region to comply with rules such as GDPR or HIPAA and so on and so forth. And then when you go down a couple of different layers, now we're still kind of in the cloud space over here in our edge compute, but we're kind of blurring the edge, the boundaries between the cloud and your on-prem environment. And these are ones where they are going to be as close to the end users as possible, which further obviously reduces the latency and bandwidth usage. But over here, so you'll have things such as your cell towers, your branch offices that could still connect to the internet on cloud compute and or have a blend between the two, right? So for things like telecommunications, of course, you have edge computing that gives you real-time analytics of network performance, kind of giving you network traffic improvements and delivering better services, or things like we talk about more in the future, smart cities, where you have edge compute kind of analyzing your traffic data, perhaps, or optimizing your light timings, or look at how utility usage are for different regions of a city. And then so you can then more efficiently, like the smart grid concept, pipe energy to where it's needed. And then after that, we go into the more localized edge layer. So your far edge layer and the consumer deep edge, I'll kind of put them in one bucket over here. But these are your more on-premise type equipment. So these are going to be a single or perhaps two servers or routers that can exist in hundreds of thousands or even millions of locations. which serves a relatively smaller workload. So, in things like retail or healthcare, where you have the retail stores, your edge compute and labs, and we'll talk about these use cases later on as well. And then perhaps in things like manufacturing and IoT, putting your devices out further where you have slightly reduced bandwidth. You don't want that traffic going back and forth really constantly, but you still need that compute on-prem. And then you've got the deep edge layers, which is all your mobile phones, your Internet of Things devices, perhaps devices on ships or trucks, your Raspberry Pis, and so on. So those are kind of the different terms that we'll perhaps be using when we talk about the edge. So some of the essential requirements that we have, perhaps for the edge, and we put them kind of in the 7 different areas. So we talk about security, making sure there's telemetry data, the data coming back through, making sure operations, you have low impact, zero application downtime in your edge environments. Of course, it's critical because when you talk about the more consumer edge, you're talking about hundreds and thousands of locations where perhaps you only have a few IT staff that could do management. And the folks at the stores are typically not as technologically proficient and or even not have the access to be able to do any troubleshooting and or remediation. So you got to make sure that your operations is seamless and have an efficient, high degree of automation and self-healing capabilities. We talk about open standards, making sure that a common standard that can abstract away APIs, and also with flexibility and mobility of your workloads, right? So you're not kind of stuck on one platform because of the standards being equal throughout all the different environments. You could use your workloads perhaps on the edge, in your data centers, in the cloud, in your near edge, and be able to port it between the different areas. And you don't have to customize your workload for different layers. Stability and predictability, kind of a given, is kind of ties hand in hand with operations and performance. Typically, when you're on the edge, you have reduced hardware and resource constraints. So whatever you're choosing in order to host your edge workloads, of course, kind of needs to get out of the way of your actual workload and be able to make sure your workload performs just like you expect it to in any other environments as well. Which then brings us to resource management, making sure that whatever your workload is running, we could actually pipe enough resources to it. So with those essential requirements, kind of thinking, yeah, Kubernetes kind of makes sense because it covers and checks all the boxes, right? It's got the stability, it's built for large scale operations. We've got plenty of monitoring within Kubernetes and telemetry. Operations is central. You also have things like, fault tolerances, making sure that your deployments are always up. It is an open standard, stable. We do have resource management, although performance, when you talk about vanilla Kubernetes, we know it's a bit more heavy rate. So we perhaps need to look for some more lightweight solutions, such as k0s, which is designed for the edge. If we kind of know then we're gravitating towards Kubernetes, let's look at how that will play within the different scenarios when we talk about edge compute. So first of all, let's look at retail, which is, of course, related to our everyday life. And I've been speaking to a few customers in the retail industry as well about this, where they're looking at, of course, deploying their workloads onto the edge sites, their stores, pharmacies, perhaps, or even when you talk about banking, taking some of those workloads and putting them onto the branch, and making sure that the branch could actually talk back and forth, and let's say, for example, to a Kafka server with ease, and then use the exact same components as their mothership data centers. So we use edge computing over here, of course, to enhance your customer experience and streamline your operations. So, you have edge devices in your stores that can analyze perhaps behavior in real time. What items are they purchasing? What times are more populous than others? So that it also enables more personalized promotions and target ads based on demographic areas, perhaps staffing, and so on and so forth. And of course, there's your point of sale systems that could facilitate efficient use of your point of sale systems, transaction-wise, and also inventory management. So Ideally, what you probably want to be able to do, and I know that one other big brand kind of DIY retailer is doing this and putting kind of more consumer grade machines onto their sites and not having kind of dedicated servers and so on and so forth. So there's any issues, just drop right in there, specify, get another server, make sure everything's good, and then hook it right in. Right. So when you talk about the benefits of Kubernetes over here, the scalability allows you to scale your applications on demand on those edge locations, depending on the workload. So making sure that your retail and POS systems, if you need to add additional folks in there, it can handle those loads during any hardware changes and so on and so forth. High availability, of course, is essential for a retail operation. If your POS system is down, you can't get any payments, right? So it allows you to manage and deploy your application instances, and if anything goes down, bring it back up right away. And any updates to your stores. So one of the things that I've heard from folks when we're talking about, retail store environments is, how do I deploy my workloads onto the store, right? So I've got a new analytics platform I want to deploy onto the store, or my point of sale system gone through an update in the inventory management update. And traditionally it's things like a batch process that runs overnight. You fire it, you have it deployed to the stores, fingers crossed it works. So with Kubernetes, you have your rolling updates, you have your deployments, making sure that if things don't go through properly, Kubernetes handles out that orchestration and makes sure that workloads gets updated to your edge locations. And of course, that depends on the architecture as well. And we'll talk about that later on in how we set things up. And of course, the portability aspect of Kubernetes, make sure that you can make sure that whatever your inventory management system is running on your edge is the same as your perhaps more regional sites, larger data centers, or even within your development environment. So whatever you're developing is exactly what people are going to be using at the edge there. Right. The second scenario, manufacturing control monitoring, a big edge use case over here, where you want to run your workloads directly on the manufacturing floor, orchestrating different perhaps manufacturing robots or logistics robots, or even your fleet management and so on and so forth. So it plays a critical role in optimizing your production process and also quality control. So over here, we have, again, two different layers, kind of your consumer edge and also the far edge, looking at the plant management servers, and then also the IoT devices on the individual machines. So again, Kubernetes allows you to deploy diverse applications, right? Your real-time monitoring systems, your maintenance tools, data analytics, or even your robot deployment software, making sure that all that is running properly on the plant. And then that could then feed into your IoT devices. And again, your fault tolerance and orchestration is essential to making sure that your plant runs smoothly and efficiently, right? So even more so than retail, if something stops at a plant, the whole supply chain gets affected. And we've all seen that when we talk about the value stream and the manufacturing stream. So again, resource optimization and making sure that your integration with things such as your automation systems, your IoT platforms is going to be essential when you're talking about these environments. The third environment that I've kind of spoke to folks about are more on the scientific processing. And then this is your medical healthcare environments as well. So we've got lab environments, perhaps, that is running, some labs are pretty small. They're probably the same size as my living room, perhaps, or half an apartment block, where you don't really have space for massive racks of servers in the lab. They could essentially just have one PC sitting there, but they're processing gigabytes and terabytes and petabytes of data because of all that laboratory analysis. So these are things that would be pretty efficient if you want to string them back and forth from your lab environment to your data processing center. So of course, you're going to make sure that your lab environment, even though you're using consumer grade products, have enough compute to go through all the analysis that you need and only report back the essential results. Which means one thing for the Kubernetes platform, if we're going to use Kubernetes over here, and that is the Kubernetes platform needs to stand out of the way of the workloads, right? So you got your CPU, you got your RAM, you got your data networking planes coming back and forth. If your Kubernetes platform is taking up valuable CPU or RAM, data analysis is going to take longer than it needs. So you need something very lightweight and kind of out of the way in your lab environments, right? Telecommunications. One of our largest customers is really is also a telecommunications customer here in the U.S. that provides just about all of mobile. No one uses home phones anymore, but internet, TV, and all that. And that kind of with 5G and also with your cell towers and everything, edge computing kind of brings the data processing closer to the end users, right? Improving your network performance, reduces latency, which is the whole point of 5G in the first place. So with things such as, DPTK, Linux fastpath technologies, and then with things such as the k0s distribution for Kubernetes, you're able to take your agile, build kind of edge devices where you have agile edge routers or even fortified security gateways, right? So over here, you kind of want to have low latency data processing. So again, your Kubernetes platform, when you're creating new pods, perhaps, or when you're creating new workloads, you need to make sure that you have low latency and high thresholds to be able to keep up with the demand and the workloads. And also that allows you to kind of support your high throughput applications, like video streaming, online gaming, and so on. And of course, with this, you also need dynamic load balancing and traffic management because demand does fluctuate, and we all know if the internet is slow, we all complain. Personally, I'm guilty of that as well, right? If anything happens to my internet, that's worse than not having, food, right? So once again, being able to quickly scale resources, being able to get out of the way of your data processing, getting out of the way of your data transfer, and so on and so forth is essential for your Kubernetes platform over here. And then last but not least, if you look at the remote field, military, other scenarios, or your first responders, our Kubernetes Edge computing solutions gives you, again, the agility, scalability, but more importantly, the resilience, which is kind of essential for first responders. You have, I've heard of folks kind of talk about deploying workloads onto military grade implement, right? Your people transport, your guidance in weaponry, and using Kubernetes there for robustness. But then when you're talking about military grade side of things also, you're talking about security. So things such as FIPS 140 validation compliance in the full tool chain is essential for these type of scenarios. So you need to make sure that your Kubernetes platform does meet all the boxes as a security aspect as well, both of data in transit and also data at rest with proper encryption mechanisms. So these are things that you need to look out for when you're looking at these environments. So once again, when you're talking about perhaps the first responder environments, the CPU and RAM networking, all that, of course, is essential. But then fault tolerance is going to be the most critical side of things. So making sure that if anything goes wrong, that workload is still going, right? I lost connection to the mother cluster, the control plane. Doesn't matter. Workload is still running without any issues, and that's what Kubernetes excels at. And then security with things such as role-based access control, the encryption, and so on is going to be essential for these scenarios. So with all that, we kind of have a sense of, what, Kubernetes seems to be the right answer. But at the same time, vanilla Kubernetes is pretty heavyweight. So what can we do in that sense? Well, we probably want to use a lightweight Kubernetes distribution, such as k0s. And so, from a technical perspective, we've already talked about the benefits of using Kubernetes. Now, from a business perspective also, it allows you to use things that are already been developed, tried and tested for you in the community. And with something like k0s, we even paired it even further down into a lightweight distribution that could run anywhere. So you essentially have a lightweight Kubernetes platform that is going to be exactly the same for any cloud environment that you have, bare metal environments that you have, or even Edge and IoT devices that you may have on things like ARM7 and so on and so forth. And it is open source, which means you have the power of the entire community behind you when you're looking through this, and it reduces the complexity of installing a fully fledged CNCF certified Kubernetes. So we know we have all the different components in there. So the way that we do that is k0s is distributed as a single binary with essentially zero host dependencies apart from just the kernel, right? And that allows us to be able to be more flexible and also be more agile when we're talking about OS upgrades and vulnerability patching, which is essential for your edge environments because that is the closest to all the other things. You're less locked down. There's no firewall in place on the edge. You're more open to other attack vectors. So your attack surface is quite high out in the edge. So when we talk about security, we've seen Kubernetes with partial FIPS security compliance. So how do we make sure that perhaps in your military, your healthcare, or even your retail and banking, how do we make sure supply security compliance for critical applications if only part of it is FIPS compliant? So when you look at k0s cores and all the OS dependencies and all the components on top can be compiled and packaged as 100% FIPS compliant distribution using proper tool chain to then match whatever your security requirements are for compliance. Now, one of the other things when you're looking at Kubernetes, those of you that have dabbled with Kubernetes before, you know it's a pretty heavy lifecycle management. There's a high minimum system requirement, and there are some OS and infrastructure restrictions, right? So on and so forth. So k0s is designed to be lightweight at the core. Right? It has a tool to automate the cluster lifecycle management, and it works on any OS and infrastructure, and could be extended to work on other use cases as well, like your Edge IoT that we're talking about today, telco, public clouds, and so on and so forth. And you get the exact same Kubernetes experience in all of these different environments. And because it's self-contained, it's a lot easier to fix and patch any vulnerability or performance issues. Right? So case in point, last week, a new CV has been found, right? CV 21626, which is, I believe an attacker can actually gain access to the host file system through run C. That's been, I think when reported, that was last Wednesday, it was reported. And then subsequently a fix has been released by the run C team to patch that fix. And so that was last week. And then a couple of days later, we've actually put that into our k0s distribution, and a hot fix patch has been released this Monday. And as far as I know, I think we're the only vendor currently that has that patch included in our product. So this kind of speaks to the speed of, because we have a single distribution, everything is self-contained, and we also commit to making sure that our platform is the most secure. Our turnaround time for any vulnerability fixes is going to be minimal. And when you look at lifecycle management, k0 does have a couple different tooling to manage multi-node clusters through either k0ctl that does your install, upgrade, backup, etc. So all of your lifecycle management tools, activities can be processed through that tool. We've taken a step further, and with k0s Autopilot allows you to update your k0s controllers and workers using specialized plans and in an automated process. So you could set it up for a schedule, you can set it up for any updates on our release server. And once executed also, you also see the process of the plan, so you can actually monitor what's going on in your cluster. So over here, you see that we've got 3 controller nodes, 3 worker nodes. 2 of our controllers have been updated. 1 of them is still pending, and our workers are still pending to be uploaded, right? So you have a clear picture of what your entire cluster looks like all in one single area. One of the goals of k0s is also to allow for the deployment of an isolated control plane. And this is where we're slightly different to some of the other lightweight distributions, where a k0s control plane is literally just a control plane. We're taking only the control plane components, set them up as a bare bones Linux process, and you do not run any workloads on it. And then on the flip side, on the worker nodes, it's only just the worker components that are needed. All right. And so this way, all the control plane components that you don't need get taken out. You've got minimal resource requirements for your workload. So everything else can go to your CPU and RAM for your retail analytics, for your lab analysis, for your telecommunication processes, or your smart grid processes. So all that can be run and maximize your hardware for your edge or near edge devices. And then what we do is we use the connectivity service to connect the control plane and workload. So you only have one single port that you need to work with between the two different components, which also minimizes your attack surface to your controller that connects to all of your important workloads behind to your data centers. So this way we could actually fulfill all of the Kubernetes API functionalities, but you don't have to mess around with all the different port openings, which one's inbound, which one's outbound, and so on and so forth. So when we look at an edge deployment, this is what it'll look like on an edge. Right? We have perhaps a regional site that is near your locations with all of your cluster management. And in each of your edge sites, you have your worker nodes or even worker clusters. So when you talk about the edge, there are two different ways of deploying them, right? So you either have localized clusters in each of your edge environment. So let's take retail, for example. I think that's the easiest to visualize. Each retail store has their own cluster. And then all that is then managed to a central environment. So that's one architecture. The second architecture is when you have a regional site that perhaps manages a number of different stores. So let's say, for example, I'm in Toronto. So maybe it would have an Ontario regional site or Eastern regional site that manages things like Ontario, Mississauga, Scarborough, and so on, right? And then when you're looking at the US, you perhaps have a greater Dallas regional site that does Dallas-Fort Worth and so on and so forth. So, and then all that manages the edge locations in your environments. And you see the resource requirement is pretty minimal in your worker nodes. We're looking at bare minimum 1 vCPU, 1 gigabyte, which means everything else can be really kind of left for your own workloads. And when you think about this, then, okay, we got the controllers, then we got to make sure that nothing goes down. So we can actually set this up with high availability using the standard configurations, right? Multi-nodes, load balancing, SCD is co-located with each of the nodes, and then you set it up for high availability data store. But then we've actually made it simpler for you using a new solution that we released just last year called k0smotron. So k0smotron reduces the footprints of your Kubernetes control plane layer. So when we're talking about control planes, you're looking at deploying them in separate nodes and so on and so forth, right? So what does that even mean? Let's look at what k0smotron does. Now, before k0smotron, we've all seen this setup before. We got your management cluster, which needs a number of controllers. So we're doing a minimum of 3 because we want to make sure you have high availability. We have our worker nodes here. And then for each regional cluster, you have, again, the 3 and the workers. And then another regional cluster, you got the 3 and workers. So you have a lot of cluster sprawl, right, because multiple clusters are managed differently with the different controllers. And at the same time, you have your control plane overhead because each cluster you spin up, you're taking up 3 workloads by your controllers. Do another one, you're taking up 3 workloads. So with k0smotron, we take this, and because of the true control plane and worker nodes, worker plane separation in k0s, we could reduce that footprint and standardize all of the control plane activities and centrally manage it in a management cluster. And then deploy just workload clusters in your individual workloads. So you have essentially your own managed Kubernetes in your environment. This is akin to what the public cloud providers are doing with things like k0s and EKS and GKE and so on. When you manage the control plane and then you deploy just the worker clusters onto your edge environments. So Cosmotron essentially is Kubernetes and Kubernetes. So it allows you to run the control plane workloads in the management cluster as Kubernetes, which means you get all the benefits of everything you have with Kubernetes. That simplifies your cluster operations, right? So you could declare how many control planes I need, how many resources do I need to do it? Do I need high availability? All the networking, all that is managed for you because you're now working in Kubernetes. And they're all based on the CNCF conformant distribution, which is k0s. So, you could have perhaps a central management cluster, which we call the mothership, that can have multiple control planes controlling multiple environments as well, one for Hetzner, one for AWS, and now with Cosmotron Anywhere, also on your bare metal machines, which I will demo a little bit later. And what you see over here, you then have your management cluster that can then have multiple control planes that then connects to your multiple workers. With just the control planes, okay, we've simplified the control plane management, but you still need to deploy your clusters. So in conjunction with Cluster API, which is also a CNCF project, we've managed to make the cluster deployment much simpler for you as well. So these are essentially things that should be together since day one, right? So what you do is we've got our management control planes. Cosmotron deploys the various control planes for your cluster. Great. Now through Cluster API, what we also do is deploy the worker nodes for your workers, and then connects it to the control plane. So it bootstraps your entire thing, simplifies your cluster management. And again, it can be run on any Kubernetes. So you install your Cosmotron operator into any Kubernetes cluster. So it could be any existing Kubernetes cluster. Cosmotron operator will create and manage k0s control planes in that cluster. And you have all the lifecycle management, such as pods, config maps, and things that will run the control planes. And then you take that and you can then deploy the worker nodes using Cosmotron as well. And this way you get the high availability and auto healing functionalities of your, what we call the mothership cluster. So with Cosmotron Anywhere, you essentially set up your nodes there, like your normal process, you set up SSH access into the nodes, and then we'll just go ahead and bootstrap it, install everything that's needed, connect the remote machine onto your environment, and then that kind of takes away the complexity of managing your infrastructure. So what I'll do is let me go through and have a look at, let's have a look at what the installation process of k0s looks like and Cosmotron. And we'll see if we can actually have the entire mothership running and deploy a cluster within the next 20 minutes. There we go. So here we have our terminal. And what I'm going to do is I'm going to start by installing k0s onto an environment. So what I've got set up is 3 VMs on my laptop sitting next to me. They're relatively lightweight because it is a laptop, so I can't really spare too much resources. And let's go ahead and connect to one of those. And what we're going to do is let's really go through the process of installing k0s onto this machine, right? So installation of k0s is a single binary, so we're just going to get a script and execute it. All right, let's go ahead and install. Timing now is 12:37 Eastern time. Let's see how long this takes. Okay, there we go. It's downloaded, it's executable. I'm going to install the controller and put this as a single node. So what this will do is it'll actually install k0s on this VM instance as both the controller and the worker. So I could actually run workloads on this machine. You could also install this as just controllers or just the workers and connect them up. But then since we're at a single instance, I'm just going to do it that way. All right, let's go ahead and start it. Start. Okay, so this way I've got k0s going. And then I'm just going to make things a little bit easier. We got kubectl is included in k0s to do all of the Kubernetes environments. So I could look at get nodes, and I don't have anything here yet. But I'll do have everything available here. Okay. Now with this, I'm going to go ahead and install Cosmotron onto my Kubernetes environment. Right. So if I go ahead and again, apply the single command for k0smotron on. This is all on the k0smotron website as well. There we go. All of the resources required for your k0smotron management is installed as custom resources. So you got cluster management, controller config, workers, and so on and so forth. And then the last thing I'm going to do is go ahead and install cluster CTL. All right, so this is the cluster API components underlying k0smotron as well. So we get both the control plane management and also the worker management. Okay, I'll install it into our environment. There, we're done. How long do we take? About 2 minutes. So now I've got a working mothership k0s instance that could allow me to deploy both control plane components and also worker nodes onto different environments. So now that the installation is complete, let's go ahead and have a look at, get that out of the way. Let's have a look at the actual cluster, all right? So in our mothership cluster, we've got our k0s controller. If you look at this, you see it's pretty small. Instance over here, I've only got 2 vCPUs. It's not a lot of RAM. I think I've got 4 gigs deployed over there. But regardless, let's have a look at how we could deploy an entire cluster through k0smotron using declarative programming. Okay, so let's go to my Visual Studio Code. So what you see over here is, let's say, for example, this is a demo store that I want to deploy. Okay, I want to deploy a cluster onto my edge location. So in my specs, I've got my cluster information, my control plane configuration, the definition of my worker machine. So this, along with Cluster API, allows you to provision machines. So this kind of extracts the way, provision machines, and will instrument k0s onto those machines and connect them into the cluster, right? So here I'm going to point to my my worker machine over here. Got the port. Just for internal purposes, I'm using root. And then all we need to do is make sure we specify an SSH key to actually connect to the machines over there, right? So what I'm also going to do is, let's go ahead and quickly create the secret for k0smotron to use, right? So I saw the SSH key just now. So let's go ahead and create a secret. So kubectl, create secret. We're going to do a generic, and I'll call it my SSH. And I'll just take my key and put it into the value section. Users can G SSH, and I'll take my my private key and then create it. Oh, it's already there. Oh yeah, that's because I was testing before, right? So with this, we've got an encrypted version of the key, and that's going to be the one that we're going to be using to deploy our machines as well. And this way allows your mothership cluster to connect to the machine and instrument all of the different components that are required. Okay, so let me quickly go into the right location. I can't remember the folder. Oh yeah, my stores. Okay, so over here, I've got this configuration file that you just saw over here, and we're just going to execute it to create the actual cluster. Right? So let's go ahead and apply. And now what k0smotron is going to do is it's going to create the cluster, both create the control plane clusters. So over here, you see we've got the cluster created. We've got the store machine created, the actual node that we're going to connect to, and go through and deploy all of the different components required for the control plane, right? And then it's going to take a little bit of time for, there we go, the kube config to come up. And this way, we could then go ahead and connect to the actual cluster and deploy our workloads. How are we doing with time? 12:43. I think we're still good. All right, so let me go ahead and get my kube config. So I'm going to do cluster CTO, and I'm going to get the kube config from my machine using the secret here. So, but over here, I got store one cluster. Okay, and I'm just going to pipe it into my configuration for lens, and I'll give it a, let's call it store one cluster.conf. So lens, being a Kubernetes management IDE, monitors some folders for any additional configuration that comes up. So if I go ahead and create that, I could then go ahead and see that cluster show up here. See that configuration file that I just created. And let's go ahead and just add it to the hotbar so I could actually manage it easily. Try to connect to it. There we go. My cluster is up. Let's see, my node's up. Perfect. Let's see how big our node is. Yeah, again, relatively small. I kind of spec them about the same, 2 vCPUs, 4 gigs of memory. You got everything available for you to use there. We're just going to give it some time to spin up all the workloads and for it to run properly. All right. So it could take a little bit of time there for it to work. Okay. So as you can see over here, we got a mostly functional, this is still taking a little bit of time to work with, a mostly functional cluster up and running within, I think we started about 8 minutes ago. So within 10 minutes, I've gone through and deployed a management mothership cluster for k0smotron using k0s. I've gone ahead and deployed a cluster. So that means deploying the control plane components for the store cluster that I have over here. It is now deploying all of the worker components into my worker node. And I'm just waiting for my metric server, but I think at this point, we're almost good to go. Right, there we go, it's up and running. So now we got a fully functional cluster within 8 minutes, actually 2. Let's see if it works. So let's go ahead and I'm gonna take Kubernetes up and running. I like this. I'll go ahead and create this pod, get it up and running. And then I'm just going to port forward this really quickly so I could actually test it. All right, I'll do, let's bring it to 8080 so I can actually see it. All right, and let's verify our deployment. So let's, I'll bring up a new browser window over here. Okay, let's do 8080, go. And we've got our workload up and running, all within 10 minutes. So this hopefully demonstrates to you the power of having a lightweight Kubernetes distribution, being able to quickly install a cluster into an environment that's just relatively lightweight, being able to then quickly put in k0smotron, which allows you to manage multiple clusters, multiple control planes, and even now deploy multiple child clusters all within one single area. And we've been able to deploy an extra child cluster within an edge site, quote unquote edge site, within reasonable time. Okay, so like I said, we just looked at what k0smotron anyway essentially did in order to deploy the clusters. And hopefully that demo was illustrates the fact. Okay. So, if everything we talked about over here is of interest to you, remember k0s, both k0s and k0smotron are open source projects. Please feel free to visit the actual 2 project sites for k0s at k0smotron.io and k0smotron at k0smotron, k0smotron.io, and test it for yourself. Right? See, work on, experience the ease of use, what we essentially just went through a whole lot. And of course, if there's any comments or any feedback on today's webinar, any questions you may have of your use cases, feel free to reach out to me at any time at my email address. My LinkedIn was here earlier. I'd love to hear your scenarios and also discuss with you how these can actually help you in your journey to the edge. So once again, it's been a pleasure to share this information with you to demonstrate capabilities of k0s and k0smotron. So I'll wish you a great rest of your day. If you have another day to go, or if it's evening, have a good rest. And it's been a pleasure to share this information with you. Hopefully I'll see you in a webinar in the future. Have a good day.